Hi, hello. Today we are going to talk about another coding pattern, subset. So after this video, you will be proficient to identify any question which is related with subset coding pattern and you can easily solve them. So our flow of discussion will be like this. First, we will talk about what is subset. Then we will see what is combination and permutation. Later, we will find how we will identify the problem. And then we will talk about what are the steps to solve these subset problems. And then finally, we will look at that what will be the coding template that we are going to use to solve these questions. On the right side here, I have mentioned a few questions which are related with subset coding pattern. These questions are from Leetcode. You can practice them. I have mentioned their number and their description. So there are many of questions in interviews. There are a lot of questions which are related with subset coding pattern, and you can just apply the same and easily solve them. Now let's go to the first point. So what is subset? Subset coding pattern is very helpful for solving any problem which are related with combinatorics. With the help of backtracking, we can solve them easily. So let's go to the second point where we will talk about more about combinatorics, combination, and permutation. Let's go for that. All right, let's talk about combinatorics. So it is a branch of mathematics that deals with the study of counting, arranging, and selecting objects in a particular way. Let's understand with a very simple example, and later we will go deep down to better understand. Suppose you are given a set. Now we are going to ask you provide all subsets from the provided set. What we can do, the first step, we will take an empty set and then we will iterate through all elements one by one and add them to all existing sets to create subsets. Let's say first we will take an empty set. Now when we are going to iterate through these elements, so one by one we will pick them and we will add in all existing sets. So we will pick the first and we will copy the all existing sets, like empty is already there, and when we will add one into empty set we will get one. So these are all subsets when we have only one element. Now pick the second one too. We will copy all existing subsets like this, empty and one, and now we will add two in all of these subsets, like we will get 2 when we will add 2 in an empty set, and we will get 1 and 2 when we will add 2 into 1. Now pick the third element. In that case, we will copy all element again, empty, 1, 2, 1 and 2, and then we will add 3 into all these elements. So what will be the result? When we will add 3 into empty set, it will give us 3. When we will add 3 here into 1, we will get 1 and 3. And then we will add 3 into 2, we will get 2 and 3. And so on, we will get 1, 2, and 3. Now here, at this line, you can see we have all those subsets which are required. And you can count them. They are 1, 2, 3, 4, 5, 6, 7, 8. So when we have 3 elements provided and they're asking for all subsets, we are going to get number of elements 2 raised to power 3. So these examples belong to combinatorics. Now we will go deep down to better understand what is the word combination and permutation, and we will further go their subcategories to better understand, and all those questions are related with subsets. Let's go. So when we are talking about combinatorics, we can divide it into 2 further subcategories. The first, combination, and second, permutation. So combination and permutation, these 2 subcategories are related with ordering. What does it mean? I'm saying that there is, so in combination, ordering is not concerned. Like A1 and 2 is when you're given 1 and 2, that's a combination, and this is also equal to 2 and 1. We don't care about ordering. So 1 and 2 and 2 and 1 both are same. But in permutation, we do care about ordering. So when we are talking about permutation, in that case, 1 and 2 is one answer, like the possible candidate, and 2 and 1 is another one. So these two are different. So in permutation, we consider these two elements, but in combination, we take care only one. Either you provide 1 and 2, or you provide 2 and 1. So further, in combination and permutation, we have further categories with respect to repetition. Means in combination, you can repeat element. So that's another category further. Or you can't repeat, so no repeat. So that is another category. And in permutation, the same. With respect to repetition, you can repeat element, or you are not allowed to repeat element. So now let's go further, and I explain with example. I'm talking about this. So we are talking about permutation and when we can repeat element. So such example, you can see there's a safe lock. You have a safe and you can make a permutation of numbers. Let's suppose you get like this, and here you can see there are some boxes here, and where you can pick, let's suppose out of 0 to 9, you can pick any number at this point. So you have an option at the first place, and again you have an option in the second place, and you have an option in the third place. So this is what we have this category when we are saying permutation and repetition is allowed. So this is a safe lock, and this complexity goes to n raised to power 3, number of places provided. Now let's talk about the second part, when we are not allowed to repeat. So in this category, when we are not allowed to repeat in permutation, so in that case, this is an example when we say who are the first 3 candidates in the classroom. So in that case, if we have, let's suppose 20 students in a classroom, so in the first 3 positions, only 3 different students can appear. So in the first place, we have the option of 20. We can pick any one out of 20. And the second place, because we have already selected 1 here, in the second place, we have the possibility of selecting 1 candidate out of 19. And in the third place, we have 1 option out of 18. So this is the example where we are talking about permutation, no repeat allowed. Now let's go with a combination. So in combination, we are going to talk about when repeat is allowed. So this is little tricky example. If I'm saying that you go to the shop and you say, you have the option to select ice cream scoops, that which one you want. Let's put out of 10. There are 10 different ice creams, and which type of scoop you want as a combination. You have option of 3. So you can pick 3 different scoops or 5 different scoops. This example related with ice cream and having your choice of scoops. So what I'm saying that let's suppose you have 5 different types of ice cream, and I'm talking here. All right, so you have 5 different ice cream and you have 3 scoops option. So what you can do, you can choose chocolate, or you can take chocolate and ice cream, like vanilla and chocolate. But this is the same, that category is same when we say chocolate and vanilla, because ordering is not considered in combination. Now let's talk about combination when no repeat is allowed. Such example is related when in your classroom you say any 3 candidates who have volunteered to clean the classroom. So there is no ordering is considered, because we are talking about combination where ordering is not considered. And any 3 candidates mean that they are not scaled with 1, 2, and 3, because 3 candidates who are going to clean the classroom, they have same level. So such example is related with combination, no repeat. So all these examples and questions are related with combinatorics, and there is one champion to solve them, which is subset. Let's go with the third step. So in the third step, we are going to identify the problem. That is it related with subset coding pattern or not? More or less, you already know that how we will identify. So in simple words, whenever you're given a set and like you have a data structure, which is working like a set, and you are being asked to generate a series of subsets considering some particle condition. So you have to generate subsets and you have to consider some particle condition. So all such type of problems can be solved using subset coding pattern. Pretty simple, huh? So whenever you will see in any question there is some set or some given elements were given and you are being asked, all right, come on, generate some series of subsets, and you have to consider this condition. And when we are talking about considering given condition, there comes backtracking. Let's go with the next topic. All right, so in the last step, I'm going to explain these 2 points together because they're very closely connected. So what is backtracking? Let's see with an example and then we can go deep down. What is that? So here is an example. So in this example, we are given 3 colors, blue, green, and yellow. There is a condition that blue must be in the middle. I am going to make a state space tree. So here you can see that this is the position, first position, second position, like position first, second, and third. So what I'm going to say, considering that condition, I'm going to say first position will be blue and second will be green, third will be yellow. So here you can see in the first row we are saying which element can come at the first position, blue, green, yellow. In the second row we are saying first is blue, second is green, first is blue, second is yellow, first is green, second is blue, like this. So that makes a picture for you. And in the third one we are saying, so you traverse the tree like this, first blue, second green, third yellow. So at this leaf node I have mentioned blue, green, yellow. That's the end result. Now let's go back to the condition. If we have this blue must be in the middle, that condition is given. In that case, considering this condition, we are not going to visit some nodes, obviously, because they are not satisfying our condition. And we will only consider those nodes which have potential, which give some result, which may be the possible candidate. So here, if you will see, in this path, blue comes at the first node, we can get rid of all that flow we are not considering, because blue already at the first position. So backtracking is saving us not to go at this branch, and we save some iterations. And we came back to the initial state. Here we are saying the first will be green and second will be blue. Perfect, sounds good. And that will be our correct candidate. This is a possible arrangement of colors where blue is in the middle because it is satisfying the condition. And here when we come across this node and in the second position we can see this is yellow. It is not satisfying the condition. We're not going to traverse this part. So we will go back, and in the third part we come here. Yellow is at the first position and blue when it comes on the second place. So we get this possible candidate where blue is in the middle. We are going to consider like a possible answer. And here green is in the middle. So we are not going to traverse this path. So now when we come to the main definition, when we are talking about what is backtracking, so backtracking you can consider like a selective tree traversal, sort of refined brute force. So at each node we are eliminating choices which are not possible with respect to the condition, like here we explained, and we proceed recursively to check only those nodes which have potential, which satisfy our condition. So after understanding backtracking, now we go and understand what are the steps, the coding template we will use to solve problems using subsets. Alright, now we have the concept what is backtracking. And now we will look for a coding template that will show that how we have to approach questions, the problems which are related with subset coding pattern. For the sake of an example, I can pick a question. Let's suppose we are given some set of numbers, say 1, 2, and 3, and they're asking we have to provide all subsets. So required is all subsets. So how we will do that? So very simple. You have to take a list which will be working as an answer, and we are going to call a backtrack function. This backtrack function will take, let's suppose, a temporary list here and a starting index. And this backtrack function, when we are going to write it, backtrack, which is going to take a temporary list and the starting index. Now here in the answer, we are going to save whatever right now in the temporary list, and here we are going to iterate on all the numbers. We are going to iterate on that for loop or for left, whatever, we will do that, and we will iterate all of the number. And here with every number we are going to first add it in the temporary list. We will add it here, let's suppose number at index I, and then we are going to call backtrack again with the temporary list, whatever we have right now, with a new added element, and we are going to call with the next number. And here we are going to remove this number, the last number, from the temporary list, so that we can go back to the previous node and can consider other options from there. So here we are going to remove last one. That's the whole template. Pretty simple, pretty easy. And if I will write it as a clean code here, it will look like something like so. Here you can see. So here you can see pretty easy that we are given some numbers as a set nums. We are taking the size of the numbers element. Then we are going to create answer list. Here we are going to call the backtrack function with the temporary list as an empty and starting index is 0. Here we are saying backtrack initially whatever we have in the temporary list, just add it in the answer. Iterate on all elements, and we add the first element here. So if I will just show you how it is working. So at the very start we are saying this is our answer list, and initially it is empty, it has nothing in it, and that is our temporary list. So in temporary list we have added nothing. Initially it is empty. So here we are going to add empty list at this line. So we are adding empty list. And now when we are iterating here using for loop, so we are at this point, at this line, you can see we are adding the first number, which is 1. So that is the tree, how it will look like in the temporary list. That is the initial, we are empty list. Here we found 1, we are going to add it, and we are calling this function backtrack again. It will come back here, and at this point, at this line, where we are adding this answer that at temporary list. Now temporary list has 1 in it. So our answer will look like this, 1. Now this iteration will move forward again, and it is going to consider element 2. So element 2 is going to add, this number 2 is going to add in this temporary list again. And this temporary list already have 1 in it. So we will get temporary list as 1 and 2. And we are going to call backtrack function again. It will go back. We will add this into our answer. Now, when we go into our for loop again, it will pick the last element and it will generate 1, 2, and 3. So this temporary list right now has 1, 2, and 3. We are calling backtrack function again, and we are providing the next element. So when it will go back, it will add this answer, like a final answer 1, 2, and 3. And now there comes the last line with the iteration. When it come back, it will say, all right, remove the last element. So it is removing 3. It will come back here, and when it will remove that, now it is, because it is already have considered 3, it will come back, and then it will go back again here, and at this point 1, it is going to consider 3. And it will add, here will be 1 and 3. Now in that case, we are going to again call the backtrack. It will be 1 and 3, and in this iteration it will remove the last number 1, and it will go back to the empty list. Now here it is going to consider 2 in this for loop, because this is a recursive call. Maybe it looks a little bit confusing, but this is how it is working. So it will call 2, and here we are going to add 2 in the final list. Here when it go for the iteration, it is looking for 3 of the 2, so it will say pick 3, and now we have not 3, again I make the mistake, it will have 2 and 3, and 2 and 3 will be added here, and it will just remove while using the backtracking. Then it will remove this and go back with the backtracking, and here in the empty list we are going to add element 3. So now when you look at this whole result, we have all subset element in it. So this is how it is working. It looks a little bit confusing because this is a recursive call, but again I can repeat that what will be our template. For sure I'm using Scala, and that template can be different. So how it will work, simply we are going to take a list, answer list, and we are calling the backtrack with a temporary list. And in whatever we have in the temporary list, we are going to add in our answer, and then we are going to iterate on all numbers. And here in different questions, we are going to add some condition here where we are short-circuiting that recursive call and just considering only those nodes which satisfy the condition. So here we are going to add then every new element which we are iterating, calling backtrack function recursively. It come back whatever it has in the temporary list which was being added here is as a whole answer was being added into our final answer. So this is the way it iterate all element using the backtrack, and that's it. We will look, there are a lot of questions which we can do and solve using subset coding pattern. Let's see and meet you in the next videos. Bye.